doing them out at the sci-fi a couple years ago.
Right.
I don't think I've actually seen them since.
No, it's years.
Yeah.
And it's like, it's really helpful too.
Yeah.
It's like, oh,
Yeah, cool. So there's just a couple short updates I'll give you guys, and then let you take the floor. I started a GitHub organization called SimPEG Research. And so the idea for this is that, like, if you're writing a paper and you want your examples posted somewhere, excuse me, then we can, we'll host them there. So you can just start a repo, like last name, year, and then a short title, because generally titles are really long. So pick something that's short and representative. And then, yeah, you post notebooks, Python scripts, whatever you're using in the publication. We won't be strict on that at all. And what I'll try and do later this week is create like a bit of a template that you can just fork and build from. So there'll be a setup.py, I'll put a Travis in there and some docs. And you can take what is suitable for your publication. So if you don't want to build docs, like if you're just deploying 3 notebooks and you don't need docs, that's fine. But if you do have like, a little bit of utility code that you want documented, then great. Yeah, so that's something, and if I missed anybody in like the setup of that and you're interested in joining, just ping me and I'll make sure that you are on there. Yeah, so that'll be helpful, I think.
And as the protocol, like we have a lot of branches, and then whenever it's merged into master, that's when it moves to that, like, what's that, research folder, or what's that?
So in this case, it should be like you'll have your own repository for your publication. So it should be pretty lightweight. And then what I would recommend doing is version it sort of based on publication. So version 1 when your publication comes out. And then if subsequently, like we've updated SimPEG and you want to make sure that it still runs, then version past that.
that might be kind of interesting to try to add some sort of a version requirement into it, so that when you look at the example that it ran for this version of SimPEG.
Yeah.
I don't know how best to do that.
Well, actually, Dieter wrote a cool thing for the notebook that just prints your environment information.
Okay.
And so, like, even something like that, like, we want to be, provide as many resources as you can for somebody to reproduce stuff.
Yeah.
So yeah, something like that would be helpful.
I've been taking a little bit of that environments.
Oh yeah, yeah.
That might be another, because you can kind of just
You just provide the environment.
provide just essentially your own environment. It's always an overkill, but I mean, that will allow people just to make an environment and then run it the example.
Yeah. Yeah. Yeah, so things like that. And then too, I mean, if you have the environment description or Docker would be similar.
Yeah.
You can deploy it to my binder as well, so then people can just run your examples. The other thing I would recommend is using Figshare. So, because like what I'm going to do for my casing paper, I'm going to point like in the paper to the repository of everything, but then each example will be individually have its own DOI on Figshare. And so it just makes it a little easier in terms of like referencing. So if somebody does want to reference a specific example, there is actually a DOI for your example. So that's kind of cool. Yeah, so I'll start like, I guess, a bit of a README and scope, and we can sort of collect ideas on how best to distribute examples. Yeah, and one other thing, so versioning too, you can version with reviews as well is also a good idea. So like send out, you get your first version when you submit, and then you get a review back, they ask you to change some figures or whatever, and then you version on that.
No, I meant the codes. For instance, while you develop the code and then under the SimPEG umbrella, then what I was asking, do I need to merge that into main SimPEG branch to put that into what was that SimPEG research repository? Or
It's- So it's up to you. We're not going to be strict on that at all. It would be definitely easier for people like to actually be able to reproduce your stuff if it's merged into master. Like for me, the casing stuff, I might not have all of my stuff merged down by the time we initially submit, and in that case, I'll provide the branch information. But I do want it into master before it's accepted, because that's, yeah, like trying to get people onto your crazy development branch is that's a hard thing to do. So that would be my 2 cents. Cool. Any other questions, things? Okay, Amy, would you like to?
Sure.
Or Dequan, did you have any questions before we?
No, I'm okay. Ready.
Cool.
Alright. I was so prepared that I even made 2 slides. 2 slides. I was just gonna kind of give a very quick overview of the current pull request that we have for NSIEM into master. It's been a long time coming. I think I opened the pull request last summer, and it's finally now kind of at the stage where I haven't worked on it very much, but I guess kind of what happened was all the other developments kind of interfered, and I just never took the time to kind of merge everything in and make sure that everything was kosher. So that is kind of happening now. And yeah, so I kind of just wanted to go through that quickly, kind of what is in there, and then what is kind of in the pipelines in terms of like stuff that I've already written but just needs to be pushed, and then stuff that I want to do kind of in the, I guess, the longer term development. So yeah, so I guess I figured I'd just open the pull request and just kind of go through it quickly. Yeah. So yeah, so the first thing there, I guess I need to fix that a little bit, but the first thing there was just to make it compatible with all the new SimPEG features. Not that it was hard. I guess we're getting a lot better at kind of when something happens, it's kind of backward or forward compatible with other branches.
Do you have like an example? Because this has been a long pull request.
So I mean, the most current is the new objective functions. I mean, not that I needed to worry about that, but I just never bothered updating from master because I was just running my stuff, and I was like, either it's like this or it's like a week of just like, what is going on here? And I just, yeah, I wasn't committed to doing that until just recently. And when I did it, it was fairly easy. The other thing was I guess the pull request initially is from when FDM and TEM were changed like a year and a half ago. And the models and the mappings, those are things too that came kind of into that. So it's just kind of because I was doing my own thing and I branched off and I didn't bother keeping up. And I guess too with like the NSEM dev was of EM dev, that was of dev, that was of master. So if something came in, it like took a while, and then I just, yeah, like I wasn't keeping track of everything that was happening and making sure. And I mean, also just learning how to work with GitHub and like doing all these things. And so yeah, it is one of those things. But in terms of, I guess, yeah, so I have a kind of a large issue with kind of overarching kind of goals and things that would be nice to add into the natural source code. And I think I addressed like 3 of those. So it's kind of a good start. That is also a year old. But in terms of the NSEM data improvements, I guess the largest ones are the fact that I updated the base data and the data class to incorporate the standard deviation floor and have a method that calculated the uncertainty, which is now coming in with, like, is now in masters implemented differently. So essentially the current, I guess, current master or the F4 solution.
It's in the simulation.
Simulation, yes.
Yeah.
Where
One question I have, and this is for everybody. So standard deviation, that's good. For, I called it noise floor.
Sure.
I mean, like, differences. Okay.
Did you change that in the survey class? Or?
It's not in the survey, it's in data. Yeah. Yeah.
Yeah.
So, but I'll let you set, because we used to call it STD and EPS. So F speed. So I'll let you set those, but again, it's really user that it's going to be on the simulation. So just like one, we might want to just pay for it.
Yeah. I mean, I don't know how. I mean, I figure the forward simulation implementation is what we want to go with.
Yeah.
But that is what I did, and that is what it is in this pull request. So that needs to be conflicted out. And then, and then I added some functions, and I mean the motivation for that was to add in some functions that actually work with the data, that kind of give you some sort of utility to do things. For example, to import EDI files, which unfortunately is the standard for MT data, and take a 3D survey and break it into 1D surveys and problems, or 1D surveys, I guess, and data. But being able to carry the data, like the uncertainty and the floor with it, and implementing plotting for the data on the data class that can plot the uncertainty. And then I had a viewer that worked with rack arrays, so kind of essentially just tables, but they're NumPy arrays, but they're in a table form, so you can index them by the name, by the column name, and then you can sort them or index them just with the index. So I could sort out frequencies and receiver types and stuff like that. But it was quite cumbersome, and I had to make some assumptions that I wasn't quite happy with. So I revamped that viewer to actually work with the data now. So now it just works with the data. And then
good question.
Yeah.
So for the textbook data, is there something you have to implement for different type of survey, or is already existing in the parent class of data? Or
in terms of,
for example, you want to index that data in terms of, for example, frequency. There's something already existing in, for example, the frequency domain EM class, or like you have to implement the same for different like NSEM, FDEM, TDEM?
I actually don't know.
Okay.
In the new, yeah, you will be able to index, like once the data is in, as long as you inherit the frequency domain data, you'll be able to index your data by frequency.
Okay.
So that exists. The thing right now that we sort of lack utilities on is really reading in data. So Cootney's done a lot of work bringing in EDI files. We have some stuff to bring in a handful of others. But yeah, right now that's probably one thing. Well, DC has got a lot of work done on bringing in data as well. So that's a piece that needs to be built out a bit more.
All right.
Yeah. Yeah, so I mean, I heavily rely on the NSEM data class. I mean, I think that's a conversation that we need to have, but I think it's getting too big for its own good, for the purpose that it's supposed to serve within SimPEG. But then we need to figure out how we're gonna then support all those utilities, how we want to interact with them. I find, especially if we are passing the data as the thing that we are working for, it should almost only care about that. And then we have a map or something that we can slap onto it when we want to view it. So for example, if you are parallelizing, that you aren't passing all your plotting stuff. And I think actually something that I wanted to bring up later was kind of hangs on that.
Can I ask you?
Sure.
So right now, I think that is your data class, it inherits base data and the NSEM data viewer, right?
No.
No.
So the viewer is totally standalone, but it inherits the plotting utils. So I can say data.plot apparent resistivity and phase,
Okay.
and it will just, I can give it an axis, or it can just do it and pop up a plot of the location, of a certain location. And I then use that in my viewer. But that kind of the motivation for that was that then you can have your data as a list and just list over or run through your list and plot it. It knows how to deal with itself, how to plot itself. Yeah, I find that because then I can't just be in the notebook and say, oh, okay, it's this location, plot this. Yeah, and I can figure out how to get out of. So I can show you guys just here quickly on the utils. So in true SimPEG fashion, my utils are just like all over the place. So I have the EDI file util that is a class that is just the importer. And currently it's still relying on the rack array. I just haven't dove in and kind of addressed that. Yeah, and then I guess what I did here is that I have the data viewer that inherits from plot utils. And the viewer is relatively small in terms of lines because it's more or less only relying on setting up, implementing the event function that actually, because it gives you a map and you can click on the location and will update your plots depending on that location. And then, yeah, just the initialization and kind of it's organized so that it has quote unquote properties. That is kind of when I was starting with properties. So I actually didn't implement the properties, but it inherits from has properties. So it was probably one of those things oh yeah, it was probably this. I needed setup, like for some reason, and I couldn't have a hidden. So it's everything needs to be kind of like brought up to snuff with a lot of things that have been happening. But it just keeps track of things as properties, and has location figure property that is the map that is selectable, and then it has a list of station figs. So in my case, I wanted to extend that into like a slice figs or like frequency maps figs or sorry, or whatever.
Does this work in the notebook?
It really depends on what you consider to work in the notebook.
Okay.
So, so currently, in order for it to be updatable, because it pops up figures,
Yeah.
you need to run the matplotlib as with the Qt backend. So what happens in the notebook when you run it, it will just pop up a window. It will take over your notebook, and you'll just have the selection. You can also run it in the notebook matplotlib notebook interface, but then I haven't figured out how to get it to update the figures. So you would have to then initiate the figure in 2 different blocks, and I don't know how to get the event loop to talk between 2 blocks in the notebook. I'm absolutely certain you can, but then again, I also think that like Jupyter Lab will just do that for you. So I can see Jupyter Lab just like you could just pop up this matplotlib whatever thing, and then this one, and once you click, it will all update. So I kind of, as much as I love matplotlib, you are able to do a lot of interactive stuff, but it's definitely not designed for that. So I've been using Bouquet a little bit, and like, it is just literally, by default, it's interactive. Like you don't have to do anything except just tell it like these are together, and like they have a function for that. So kind of, I guess the next kind of with this is to update it into a truly interactive platform. But then just to show you here, the plot utils then are like a much bigger thing. And I implemented, it is a little convoluted, but so I have what I call the base plots that are kind of more meant to be standalone things and are updatable. So that is what the viewer uses. So for example, here it's for taper amplitudes, station plot. So it makes a very specific view on the data, and has a setup function to set up the plot, and then it has a draw function that you can then call to redraw the plot. So you're kind of saving yourself the resetting up of the figure. So it's just updating the axes that you're working with. Yeah, so I did that for the taper and apparent resistivity phase station. And then I have data NSEM plot methods class that the data inherits, which are then kind of the lower level plot apparent resistivity. So it just plots an apparent resistivity curve of a specific location and a specific list of components. So it's kind of trying to, so this is inherited. So this you can call directly from the data. And if we look at the apparent resistivity drawing function, it is just then calling the data. And I implemented it here that way that you can give it a list and it will plot the first object in the list, the data object, with uncertainties. But all the other ones are then just overlaid, so it's kind of for comparison.
Sorry, I didn't get that one right away.
So you can plot it with uncertainties.
Do you have multiple data sets?
No, so you have multiple data, so you can think of it as like observed and predicted. And so I plot the observed with uncertainties, yeah, but the predicted just goes on top of that.
I see.
So.
They are separate objects. Predicted data and observed data are.
Yeah. Because then you can share the survey. I mean, I find that much easier because then you can keep track of your objects rather than keeping track of a vector within your thing, within your object.
And that would be the same as what it is. Your predicted and your observed are separate data.
Yeah.
Do you share the survey?
Yeah, you share the survey.
You send the survey to both.
Yeah. So I mean, once if you have the same survey object and you implement both, you initiate both of them with the same survey, they share the survey. So they are very aware of themselves or their connection. Yeah, so that's what I did with this. So this kind of the short-term tasks. I'm hesitant to give a timeline given the history of the pull requests, but I'm kind of hoping that it is kind of counting on months, maybe kind of next couple of months to kind of try to push some of these things. And the yeah, and that would be, I guess, aligning NSEM up with the forward simulation. So actually trying to catch up and being ahead for once. And that will also allow me to take some of the codes that I have and just push them then directly instead of, I think it would just be nicer. Just, yeah. And it aligns a lot better with the next one, which is FDM icing the NSEM module further. So a lot of it inherits from FDM, but some of it doesn't. So for example, the receivers inherit from base receivers. The sources inherit from base sources, stuff like that. The problems currently are aligned very well. But again, there are some things that we decided to do when I started with the NSEM to do that kind of made it such that it was better to keep it completely separate, even though it's sharing a lot. And the biggest fact there is that kind of I require two sources. So I kept track of that internally, but now I think it would be it's a much better implementation to implement it as its own source, but it just takes in two FDM sources. Currently it's its own thing and it kind of has to do everything on its own. Whereas if it's just inheriting directly from FDM, there's just much more flexibility. Same with the receivers, they don't really need to be NSEM specific, they should be FDM specific, or they should just live in FDM and be called. And that also allows us to just implement the sources as FDM instead of, and then you could just, yeah, it just opens up a huge can of worms of interesting things that you could play with. Currently it's possible, but it's just not nicely done. And I mean, I remember we sat in here and we discussed this and we decided it was a better thing to do it like this. And I totally agree. But now I think it's time to start to kind of move it, especially as FDM is fairly mature and has a lot of things that I'm like, oh, I wish I had that. Like all the different types, like all the E and B and like all those forward simulations. I mean, if I can just use those directly, I mean, it's so much better for everybody. And I think the overhead it's going to be less than what it is now, because I think we just understand the whole thing a lot better. And then I do have a lot of things that I've implemented on my own branch that aren't necessarily related to the NSEM, but I've just wanted them for my work. So I implemented logging, so I can log all of my immersion, so I can get like a very comprehensive log of what is happening, which I find really useful for debugging and kind of keeping track of what is happening at any given moment. I've also implemented factorization storage for the FDM problem. So essentially, instead of factorizing your A matrix every single time, you just store it for each frequency. And I mean, if you have the memory to store it in memory, it is a factor of approximately 5 speed up of your immersion, which is quite significant. So I want to kind of get that in. Same with some of the data / receivers in natural source. They're implemented in a very SimPEG way, which makes sense when you only have one receiver per source, kind of, or when it's kind of few receivers per source, or sorry, you have the same receiver object in multiple locations, then it works really well. But for me, I have at least 8 different receivers on multiple locations that interlace because of the impedance. So you need to solve it in a very, and the receiver object, because we store it as a real and imaginary, it's the exact same calculations and projections, and like all the math is the exact same, except at the end where you just grab real and imaginary. So you're literally doing the exact same math twice and just grabbing half of it. So just having some sort of a utility that just like, oh, that's just completely redundant. Just put it there and put it there. And then, I mean, I can think of other ways to, or I have thought of other ways, and I'm sure we can come up with other ways to try to even make it faster, storing it, like lazy storing it or whatever. But it's just, when I look at my times, I'm just like, oh, that should not be taking 15 seconds, like every time. Because you use that like, what, like 6-7 times per like step, or no, not even step, but like just, it's painful. I just never noticed it when I was running, A, when I was not running a logger, and B, when I was like factorizing 7 or 6 times, like, which takes a long time, but just, yeah. So I just optimize, so I guess optimizing some of the code to kind of both be more cohesive to SimPEG, but also be more optimized for the computations is kind of where I see quite a lot of this moving. I mean, the code works, I think, fairly well. Like it solves the problem, but it's definitely not optimized for some of those things. And then there are some new data types and utils, data utils, viewing utils, and stuff like that I want to kind of implement. And then as kind of for more long-term goals, I just put in here like kind of improve usability and increase the user base. And I think a big part of that is kind of more examples, tutorials, and different levels. I agree that, I mean, I guess I have been more or less the sole user, as far as I understand, until very recently. There are people starting, but it's kind of hard to keep track. And I mean, I'll be the first to admit, I'm not very active in keeping track and stuff, but I think having some examples that are kind of at different levels, do some of the mundane tasks that you need to do. I mean, it's a good practice for everybody to have to write their own EDI reader. It's like
so many format readers.
Yeah.
No more.
No, but like there is a time, like it has its time and place, but then you should just be able to jump onto something and just kind of use it and like dive into those things in the inversion that we just haven't. I mean, I have wanted to investigate, but just haven't had the tools. I mean, I am building this initially to be able to do those things. And I've been able to kind of chop off a couple of those things through my research, but I would really like to lower the time investment for other people that have other ideas, and they could just like, I don't know, if they want to implement boundary conditions, they can just literally go and grab something and grab Sagi's boundary condition example and my natural source example, and then just massage things together, and then all of a sudden we have an NSEM boundary condition example. Like that is my like long-term vision and motivation and goal at this point. So, and I think the short-term tasks, I guess, will help with that. Like putting it down to FDM, I mean, it just lowers the overhead of having to learn like all of these things. And since it is just essentially a a variation of the FDM problem. It just should be that. There are other things that I would like to talk, and I think we should kind of think about, but those go to the long term, is kind of the user level that we want to kind of have, and kind of how we want to deal with things. I mean, like the data. I mean, I like the idea of the data to be just like very slick. It's very, you just have your observed object, and it's just that, just with minimal information, and like uncertainty and floors, and those are in my mind required. Plotting is not, but you will require it at a different level. So it's just kind of figuring out how we want to deal with that. And same with all the input and outputs. I mean, it ultimately has to go into the data, but I kind of envision it as another API, like some sort of a data parser or data worker or whatever we want to call it, that kind of just deals with that, and it just has a property that is data. So you just make that property. So then when you are interacting with your inversion, you just say like data worker dot data is my observed. Because then you could think of like having things like manually playing with your uncertainties, or making some tools to estimate your uncertainties in a better way than just picking 5%, which is what I do currently. And then you don't need to know too much about the data. Like it just kind of, there's a util that just, okay, you do it like this, and it just pops it. Like, I don't know. That's kind of where I'm at now. About a year and a half ago, I think I gave a presentation, and I was on the other bandwagon of like having everything in data. But then we were kind of passing around just a NumPy array. So then it made sense to have like this great container of the information, and then you just pass the minimal amount of information that you have. But this kind of, I guess, ties into, I mean, just kind of the vision, I guess the quote unquote strategic planning of SimPEG. And I mean, and just kind of facilitating those, because I think there are a lot of users that would like that, just they have an EDI file and they just want to test out an inversion or several EDI files. So if you just had a nice interface, they can kind of look at it. But then it just, once you start doing that, you open up kind of you open up for the PhD killing implementation tasks that are so much more fun, but just don't get you very far in your research. Like in terms of tying in with like Bouquet and like all these like awesome tools where just like things just pop up everywhere, and just, I guess just, it's amazing to look at some of these things. Yeah, you just like, but then again, it's just, I mean, like I learned that like from SciPy and kind of from the community, like that people are just so open to people using their stuff. So if you add a small latch for people to latch onto, it's just a much smaller jumping in to implement some of these things for your problem. And you kind of get the example of like, oh, it is actually just that easy. You just import Bouquet and you say, instead of saying matplotlib.plot, you say matplotlib. Or you say bouquet.models.plot or whatever it is, the syntax. So, and I kind of feel like that it doesn't have to, it shouldn't live in SimPEG per se. Like SimPEG should definitely not inherit natively Bouquet. I almost feel it shouldn't do that with matplotlib either, because I have a lot of issues with that sometimes. I know how to work around them now, but if you're putting it on a cluster, for example, it causes you a bit of grief. You need to know how to work around it. It depends on what version of cluster software you're using. But for example, the cluster here, you need to kind of turn off. Yeah. So, I mean, but then kind of just maybe having a view on SimPEG that is just a cluster version that just takes care of that, or have a recipe for it. I think that is more important at this point. What we do with it later on, we'll do later on anyway. But for me, like some of that stuff, I would just like to make an example how to set up SimPEG efficiently on your cluster, and it just is matlab.use anything except Qt, I think, more or less. So.
One other thing that you and I talked about this weekend that I think is worth bringing up is examples and docs.
Yes.
So how, like, because I think there's a few different styles of examples, and I know that we've seen this with JIT tools, where there's sort of like the bite-sized examples and then just more like ABC type things. And I guess what I wanted to get thoughts on or get people thinking about is how people want to develop docs and examples. Because right now the system that we have, we're writing Python scripts, which is fine, and you can actually format them nicely so that it like sort of turns into a notebook style example. And so that's a nice way to go potentially. Another thing to think about doing is actually writing notebooks, and we'll have those tested. So one of the things that Judy and I talked about is maybe actually starting a notebooks sort of repository, but actually imposing some fairly high standards on the quality of that notebook in terms of like your comments, and we'll send it around for a round of peer review to make sure it really is like a synthesized, useful example. Yeah, so I don't know what people's thoughts are and like what is your preferred mode of development? What's your preferred mode when you're actually looking at other packages documentation? Like what do you want out of that?
I kind of like the notebooks idea. It would be a space to not only add comments to the code, but also sort of explaining to the user why you're doing things in a certain way. So you can run through an example and go, cool, I was able to run it. But it's a really good opportunity to let people know kind of how you're approaching this in SimPEG, which I didn't always pick up from the examples that I try to find on the website.
Yeah, I've come to really like the Bouquet webpage, I guess, examples gallery. It's kind of nice. So they have a gallery. It's similar to Matplotlib, where you have kind of these nice pictures. You can click on them, and they'll show you this like really nice app, and you can get the source code, and you can download the app, you can run it and play with it. So that is a really nice thing. Then they have kind of another level of their docs where they kind of, because it is so interactive, it's all embedded. So it's really nice. I mean, but like the actual doc strings for a lot of their functions have the output of the function. Not that we can do that, but it's a very human readable way. It's not this kind of.
Well, there's places where we can do that, like the waveforms work. That was one thing I was thinking that we could put, like that's easily embedded right in the API. It's like, what does this waveform actually look like?
Yeah.
The only drawback with notebooks is versioning them, because it's really hard. So that's something we just need to give some thought to. And so I think that like notebooks would be a separate repository. I do really like the style. Can I try?
Go ahead.
I do really like the style. I think I pushed it accidentally. I think that the gallery is kind of nice, and I do like the style where it is like a notebook styled example. Oh, I think we had it in. Yeah, so this. So
Yeah.
this I think is actually like a very readable example. And it's actually, like there's a bit, of course, that we can do to actually put more text, but it's sort of code interleaved with figures and text. This was not actually written as a notebook, which is kind of annoying because I would love to just write this as a notebook. It was written like this. So here you just have your comment box, and those are what are showing up. So this is another option. I would like to actually like push our current examples more so towards this. Future examples we can think about.
That one is actually built from, well, like initially there was a notebook before.
Yeah.
And then I think someone transferred that into RST, Python file.
Yeah.
So is there like a automated way that you could we don't really need to do a perfect job, but kind of do a okay job that we can actually fine tune.
Yeah, I mean, so NV convert will get you pretty close to this format. What's annoying, like, there's the documentation packages right now have not like figured out how to interoperate. So there's one documentation package that will actually let you write your docs in notebooks and probably compile that. There's this one that we're using that doesn't exactly, it only goes one way, so it goes from code to notebooks. It doesn't go the other way yet. Yeah, but NV convert will get you pretty darn close to this.
So which is kind of fun.
Yeah.
Even though it's one way.
Yeah.
It's okay.
Yeah.
Do it.
Yeah, I mean, so that in a lot of ways is a potentially really good option. Yeah, and then one thing that I think we can try and do, because right now we sort of have just all the examples, which is not a bad thing. But sort of think about splitting up, because what I would love to see if we look at electromagnetics, for example, is like, here's airborne limb, here is a grounded source survey. Like, go through all of the different surveys that we did. Because right now, you know, if we tell somebody to inherit FDEM to do MT, like that's potentially confusing. But if we have some examples, use case, and like when you go to the docs, you see magnitude alerts, then you realize that the magnitude alerts, which should be good. So
yeah,
that's one of them. And is there a way that we can, because can we somehow attribute like who is writing that example, like page, for instance? Because we need a little bit of motivation, because you always even though you're doing your own research, you probably do that.
Yeah.
And it's a little bit more work, to actually higher up the level or the quality of that script above that level.
Yeah.
And then if you have a little bit of motivation, I think that would be better. Right?
Yeah, sure. The RST tag, I believe, is just author. But we can double check that. If it's not that, it's something like this. So we can include that. And you just use your GitHub handle and we'll link to your GitHub page. So yeah, I think examples is a fine place to do that.
Yeah, because it would be nice to kind of add levels of examples, kind of. I mean, sometimes you feel like writing a really, really comprehensive one. Sometimes you don't. And I mean, there's use for all of them in different contexts.
Yeah.
I kind of like the examples that we have. Like, I find them, like, I kind of wish that there was like a comment like every once in a while in some of them. But like, I like that style. Like, I mean, it's kind of like matplotlib. It's just kind of very specific. It just does it. But then it is really nice to have these two. And I mean, people prefer doing, I mean, I usually just take an example and copy it and then start running with it to do my stuff.
The challenge, I think, with a lot of our current examples is they're very tailored to like us.
Of course.
Because it's tailored to somebody who already understands. Okay.
Sure.
Yeah. So that's not a bad thing, but I think like as much as we can to start pushing towards just like a little more friendly, even if all it is like step one, generate mesh. Like you at least now know that CS is somehow related to something to do with the mesh.
Yeah.
So yeah.
Yeah, we need like a little bit more like a tutorial type stuff. documentation either in this format or notebook. But I kind of like for the tutorial, I really prefer notebook style because there are a lot of like small detailed questions, and it's kind of hard to do that in that format.
Yeah, absolutely.
That little bit interactive format allows you to kind of explore.
Yeah.
And I think that's really better.
Yeah. So one thing that we can do, because I think we want to support both use cases, we can start a notebooks repository that's sort of expressively for solid examples. Because we have like a notebooks repository that's like just a dumping ground right now to just store notebooks. But I think if we have something that's, like if you've seen Dieter's notebooks for EM Python, they're beautiful. So sort of going something towards that, have that as well as the docs.
We did have a tutorial section one time. We put together a whole bunch of stuff from SciPy 2 years ago, and
Yeah,
we went through it to find some notebooks.
yeah, so that's,
It's
we just synthesize some of that stuff. So maybe like we can, let's all mull it over and maybe next week we can sort of start taking some action on it.
Yeah, it's right now like the one from SciPy are in the SimPEG presentation, and some of them are a bit outdated now. Like I took the one for gravity and light for TKC, for example, and had to do. It was not hard, but they were a few tweaks to bring in, so to make them work and compile again.
Yeah, because we do have some stuff in like computation about GeoSci.xyz. That's where some of them ended up. So I think we just need to like take stock of what we have and figure out where it should go. Okay, we've got like 5 more minutes. There were 2 more things I wanted to quickly run by. There was a bug in how we were calculating source terms for time domain inductive sources when we have permeable material. So I was alright, I don't think that would affect many of you guys. It certainly affected Alini and affected some of the casing stuff. So that's been fixed. We'll try and get that in this week. So I added a couple, like in addition to fixing that, I also added a couple of waveforms because we wanted to test them along on time against solving the rheostatic problem and make sure that those are working. And so now they are. They're not before. So yeah, 2 new waveforms. That's that. And then the other thing that I was wondering if this would be useful, I've been working on getting time domain onto the simulation. I was wondering if it would be useful if we spent half a day next week and we actually walk through upgrading the DC code together. So that would just give a chance that we'll just sit here and put it up on screen and do it. So that would maybe give a chance for people who want to upgrade, like take charge of upgrading actions and do all of that.
I mean, to like using a simulation class, right?
Yeah, yeah, that sounds great.
So sorry, Lindsay, you're talking about the DC code or time domain code?
For the bug.
You just mentioned like half day something, like it's a time domain or DC?
So, sorry, that went by fast. I have upgraded most of the time domain code to sit on the simulation now. The frequency domain and the time domain now are on the simulation.
Okay.
And so next week we'll take half a day and put the DC code on, and we'll live stream that and do that together.
All right.
Then, like, it's sort of captured how that upgrade process works.
Okay, nice. Good.
Cool. Yeah, are there any other things, questions?
I have a very quick question.
Yeah, for sure.
Anyone has tried the Jupyter lab?
Yes.
How's that?
It's pretty slick. I haven't been using it too much recently, but I was using it when like the first alpha came out, and there's some cool stuff there.
Okay, you think it's worth trying?
Yes, absolutely.
Okay, all right, that's good. Good here. Thanks.
Cool. Anything else? All right, thanks, Judy. Cool to see all of the progress on NSM.
Okay, nice. Yeah, thank you, guys.
All right.
Yeah,
See you, Divan.
See you later.